Hello, we'll be completing the last part of metallurgy chapter, that is alloys. The topics covered are alloys, composition and uses of stainless steel, duralumin, brass or bronze and fused metal or solder. What is an alloy? Alloy is a homogeneous mixture of two or more metals or of one or more metals with certain non-metallic elements sometimes. Alloys melting range of about 51 degrees Celsius to 260 degrees Celsius. These usually contain bismuth, lead and tin, and such alloys are called fusible alloys. Fusible matlab it can be molten very easily. Steel containing up to 10% of elements like chromium, molybdenum and nickel etc. usually with a low percentage of carbon, and it is called alloy steel. These added elements improve the hardness, wear resistance, toughness and other properties. Amalgam, it is also an alloy or a mixture where one of the components should be mercury with a number of metals or alloys such as sodium, zinc, gold, silver as well as with some non-metals. The dental amalgam is a mixture of mercury and silver tin alloy. And mercury does not form any alloy with iron, so it can be stored in iron containers. Now, why do you prepare these alloys? Alloys are made to change the property of their major constituents to achieve certain objective. Like you can increase the strength of iron by increasing by making a steel. Now brass is stronger than its components, chief components copper and zinc. Now solder is an alloy of lead and tin. Now tin lowers the melting point, it melts about 180 degrees Celsius. Now this is useful for electrical connections because of its melting point, which is lower than the individual melting point of its component metal. That we'll see the composition and uses in the next slide. Now another example is sodium amalgam, which is less reactive than sodium. This is a liquid alloy at room temperature. So purpose of an alloy is to improve the specific usefulness of the primary component and not to adulterate or degrade it. Means whatever good quality of the component, that can be more useful by making an alloy. So the reasons are to modify the appearance and color, to modify the chemical activity, to modify the casting ability, to lower the melting point, to increase the hardness and tensile strength, to increase resistance to electricity. Now how can you make the alloys? Like you can make the alloys by fusing the metals together. You can also make the alloys by compressing fine metals. Now these alloys are also called solid solutions because this is a solution type where solute and solvent both are metal and solid in nature. So these are also called solid solutions, like brass. Take the example of brass. Here the solute is zinc and the solvent is copper. Okay, because copper, which is acting as a solvent here, it is more in quantity. So we'll go through the composition and the uses. Like first is stainless steel. It contains 73% iron, 18% chromium, 8% nickel, 1% carbon. So it resists corrosion, it is hard, lustrous, resistant to acids and alkalis. Nickel chromium imparts luster and carbon imparts hardness. These are used for making utensils, cutlery, ornamental pieces and surgical instruments. Now go for the duralumin. It is the lightest alloy. It Its components are 95% aluminium, 4% copper, 0.5% magnesium and 0.5% manganese. Very light, hard, resistant to corrosion and highly ductile. So these are used for making bodies of aircraft, buses and tube trains, light tools as well as pressure cooker. You have to remember all the composition percentage wise, their properties as well as uses. Then is brass. It contains 60 to 70% copper and 40 to 30% zinc. You have to write 40 to 30%, not 30 to 40%, because this side if it is 60 to 40, 60 plus 40 it is 100%, 70 to 30 it is 100%. So if you have more copper, lesser zinc. Now copper is here the solvent and zinc is the solute. In every case, like here iron is the solvent, here aluminium is the solvent, others are solute. Now the properties of brass is malleable and ductile, can be easily cut, resist corrosion and the color is yellowish or silvery. Uses are decorative hardware, utensils, screws and handles, cartridge containers, parts of watches, taps, musical instruments, electrical goods and marine engines. Then is bronze. Here the composition is copper, tin and zinc. This is the difference between brass and bronze. Here in brass there is no tin. Here in bronze there is tin and 80% copper. Again copper is the solvent over here. It is hard, easily cast, can be polished, resists corrosion. It can be used for making medals, statues, utensils, bearings and coins. Then is the fuse metal or solder, which is used to do some joining of the wires in electrical connections. Here lead and tin are in 50% amount. It has low melting point of about 180 degrees Celsius and high tensile strength. TS is the tensile strength. Tin lowers the melting point. Used for soldering purposes, fuse and printing blocks. Thank you for patience listening.